How AI is revolutionizing chip manufacturing. Insights from Lam Research. The AI revolution in semiconductor manufacturing, a game changer or overhyped promise? Artificial intelligence is poised to transform the semiconductor industry as we know it. But here's where it gets controversial. Some say AI will be the savior of Moore's Law, while others worry it's just another tech bubble. So what's the real story? As chip manufacturing pushes into ever more advanced processes, the challenges are mounting. More intricate steps, tighter tolerances, and mind-boggling complexity threaten to slow progress to a crawl. Enter AI, the secret weapon that could keep semiconductor innovation on track. But how exactly can AI make a difference in the world of chip fabrication equipment? David Fried, a top executive at industry leader Lam Research, offers some fascinating insights. One of the biggest hurdles? Data scarcity. Unlike consumer AI that gobbles up internet-scale datasets, chip fabs generate limited real-world information. Fried explains how his team is pioneering ways to accelerate AI model development with these constraints. It's a delicate balancing act of squeezing every drop of insight from available data. Once trained, these AI models promise revolutionizing thin-film growth with AI, Bizmuth MBE's approach. The future of semiconductor innovation is being rewritten by artificial intelligence, but not in the way you might expect. While headlines often focus on AI's flashy applications, the real magic lies in its ability to refine the tiniest details of compound semiconductor production. Take Bizmuth MBE, a startup that's redefining thin-film growth by harnessing cutting-edge AI tools. But here's where it gets controversial. Is AI truly a game changer, or is it just a buzzword masking incremental progress? Let's dive in. Artificial intelligence isn't new. It's been around since the 1950s, thanks to pioneers like Alan Turing. Yet today, its role in semiconductor manufacturing is evolving rapidly. From classifying defects to optimizing epitaxy, AI's capabilities are no longer static. They're dynamic, growing alongside the data they process. South Korea's Ivy Works, a leader in gallium nitride, GaN, epiwafers, has been leveraging AI since 2019, but the real shift is happening now with large language models, LLMs. These models don't just analyze data, they understand it, including complex RHED images that monitor epitaxial growth in real time. And this is the part most people miss. The multimodal features of LLMs let AI interpret both text and visuals, bridging the gap between human intuition and machine precision. Enter Bizmuth MBE, a London-based startup founded just a year ago but already making waves. Its co-founders, CEO Isabella Lorente, an environmental scientist and third-generation entrepreneur, and CTO Fabian Basteman, a PhD in MBE and coding enthusiast, aren't just building software, they're crafting an ecosystem. Their AI toolkit, designed to operate at the system level, aims to become a lab operating system for thin-film growth. But how do they fund such ambitious goals without external investors? Basteman reveals, everything we've built has been earned through software sales and seminars. This self-funded approach gives Bizmuth the freedom to prioritize long-term vision over short-term gains. The heart of Bizmuth's innovation lies in its software. Over a decade ago, Basteman created EPIC, a tool to automate MBE equipment, a solution he desperately needed as a researcher. From there, he developed Nexus for MBE control and Pulse for RHED analysis. Pulse, in particular, is a breakthrough. It allows growth software to communicate directly with RHED systems, automatically calibrating tools and calculating growth rates. But the real secret sauce? The MBE Academy, a knowledge hub born from years of blog posts. It's a lifeline for engineers lacking formal MBE training, offering interactive tools like Crystalmatic, 3D crystal models, and a RHED simulator that turns theory into practice. Bizmuth's philosophy is refreshingly pragmatic. We want to walk before we run, says Basteman, emphasizing sustainable growth. Their partnerships with institutions like the University of Sheffield and HRL highlight this approach. By reviving legacy hardware and avoiding vendor lock-in, they've helped researchers avoid delays and unlock PhD-level results. And now, their collaboration with the Paul Drude Institute, PDI, is pushing boundaries further. The project's goal? Replicating GAN growth conditions across multiple MBE systems using AI. Finding the GAN growth window is like solving a puzzle with no pieces, Bastiman explains. You either get material or you don't. If successful, this could revolutionize AI's role in material science, extending its reach to CVD, ALD, and PVD techniques. The ultimate vision? A world where every lab has access to AI-powered tools and expertise, regardless of budget. Bizmuth plans to expand its Thin Film Academy to cover MOCVD, PVD, and ALD, democratizing advanced knowledge. But here's the question, can AI truly replace human expertise, or will it always need a guiding hand? As Bastiman puts it, they didn't buy a product, they bought a lifestyle. I want them to enjoy it. So, what's your take? Is AI the future of semiconductor labs, or just a tool to enhance human ingenuity? Share your thoughts below.